Hello, welcome to Geeking Out with Shad. I just checked the temperature before I left the house here and it said -7 degrees. So I want to take this for a drive. I'm not going to do the typical range test you see where they drive it to the limit, because you don't really need to do that. My car clearly tells me the miles per kilowatt hour, kind of like miles per gallon, right? And that's a very accurate gauge that I can go by to get a good idea of how much range I have when it's this cold. One of the issues is that when you first start an EV, and this is the same with ICE vehicles too, when you first start them and you got to get them warmed up, they're very inefficient and they'll take away some of the battery. And in an ICE vehicle, it uses a lot more fuel to get the car going, especially if you're just sitting there idling. I don't sit and idle with my car. I just get in it and start driving it, because it literally heats up within like 30 seconds to 45 seconds. And so there's no reason to sit and wait for an EV to warm up. Granted, if you have it actively plugged in, it's pretty smart to just start it up, remote start it, and get it warmed up before you get in, and then unplug it and then you don't actually use the battery. So that's one way to do it to save a little bit of range. What I'm going to do is go in there, look at what my battery percentage is. I want to say it's around 70% right now. Then I'm going to drive. I'm going to go to a Target that has an EV Go station, and then I want to test a few things. I want to drive it. I want to try to do over 20 miles, maybe 25, you know, a long enough drive where the car gets really warmed up and hits its optimum efficiency in this cold. Because if I do a lot of little short trips, it's not very efficient, because it never really gets to drive for very long when it's all warmed up. So you got to drive a little further to kind of get an idea of how much range you're going to get in cold weather like this. So I'm going to drive there over 20 miles. I'm hoping maybe 25, 30 miles. The Target isn't that far away, so I'm going to kind of take this long route to get there, and then we'll charge it, see how the charging goes while I'm there. I gotta go do some shopping, so I'll go do some shopping while the car is charging, and then I'll come home after charging it and we'll check it again. So that's kind of my plan. So let's get in and drive. Okay, I just started my car up. Couple of things. It's showing low tire pressure. That makes sense. It's really cold out. As I drive, the tires will warm up and they'll be fine. 71% battery left. And this car shows statistics here. The drive info, that's accumulated, and this is since charging, right? So what we're really going to focus on is this drive info. And the longer I sit here not moving, obviously I'm burning up battery while the car isn't moving, so that's going to make it, you know, throw off the figure. So I'm going to get moving. We're going to go ahead and go to my Android Auto and go to Target. It says 14 miles, but I'm gonna kind of take a long route there and let Google Maps correct itself and try to, you know, get over 20 miles or something. The heat just now kicked on and you're here for it. That's how fast the EVs warm up, which is awesome. That is so much nicer than ICE vehicles that take forever to get warm when it's this cold out. My dashboard says -3. My weather app says -7. I don't really know what the true temperature is. I tend to go more with my weather app and not with the vehicle for some reason. I just don't feel like the vehicle temperature gauges are all that accurate, but who knows. All right, let's go hit the road. So before I hit the road, I'm going to turn on my steering wheel. I'm going to put my seat heater at 2. This gets really hot. That gets decently hot. And I'm going to have it at 65. on the windshield at first, and I'm going to switch it so it's up on the vent once I am sure the windshield's warmed up. 66 is plenty warm in this car. I usually like to have it at like 68 or 70, but for some reason 66 has been fine in this car. So let's do it. So right off the bat, I've only got 1.2 miles and I'm getting 0.9 miles per kilowatt hour, which is absolutely terrible. Oh, it just jumped to 1.0. But that's going to improve significantly the longer I drive, because the car is already getting pretty warmed up. Like, I've only gone 1.4 miles now, and the car is nice and toasty inside, and I'm going to assume the battery is going to be, you know, at its ideal operating temperature here soon. And once that happens, this average should go up. Ideally, I definitely want it to go over 2 miles per kilowatt hour. Anything below that means I'm really not going to have that much range in this cold temperature. So let's see what happens later on in my drive here. Okay, so I've traveled 6.5 miles. I think I'm going to actually follow the directions on the GPS now, because it says 20 miles to target, so that'll get me like 26 miles or so driving. Doing around 65 miles per hour. Speed limit's 60, so I can't go really any faster than that. One thing I've noticed, it now says trip is 6.9 miles. The average is at 1.5 miles per kilowatt hour. Doing the math on that, that's right around just over, right around 100 miles of range if it just stayed at that level. That would not be very good, so I'm hoping it goes up from there, so we'll see. All right, I also do think that if I had went and topped off the tire pressure, I'm gonna get better range. Low tires are obviously gonna sap the range a little bit more, but we'll see. Hopefully as I drive, the pressure went up a little bit, but I want them to get up into more ideal operating temperature, so we'll see what happens. Okay, so I'm 13.7 miles in. My average miles per kilowatt hour is 1.8, so it is going up quite a bit, which is good, because now we're going to get closer to, you know, much better range. 2.6 is where I get around 200 miles of range, so we'll see how high it gets. I turned off the seat and the steering wheel because they were getting too hot. So I know a lot of reviewers or people that do these range tests, they set their climate settings and then just leave them for the duration of the drive. But what I'm doing is I want to make this realistic. This is realistically what I would do when I'm driving. Speed wise, I'm not staying at a fixed speed. I'm in traffic. I have to slow down sometimes. I have to speed up sometimes, you know, things like that. So it's just a more realistic range test in my opinion. So I am toasty warm. Like, yes, I have a couple layers on and stuff, but it's cold outside. This is how I dress in the wintertime. If you don't dress warm in the wintertime and you drive your car around in like a t-shirt or something, or without warm enough clothes, it's kind of dangerous. In case something does happen, you get in an accident, your car breaks down, whatever, you do not have enough clothes to keep you warm. So I dress warm when I go drive my car in the cold, so it's the way it is. So I still have my temperature set to 66. I put it on auto because again I was getting too warm and the windows were starting to fog up. And the cool thing about this car is that when I put it in auto, I have all the selections to just automatically like clear the windows and things like that when it needs to, and it does a really good job of that, so my windows aren't fogging up or anything like that. So that's kind of cool. So yeah, we'll keep this going. I'm at 16 miles. Still says 1.8 miles per kilowatt hour. I have a feeling that's going to improve throughout the drive. Been driving for 21 minutes. All right. Okay, so I have arrived at the charger. We're gonna look at some stats here. So it shows 2.0 miles per kilowatt hour. Battery is down to 53%. This was still going up, so I have a feeling if I drove even further, that would even be a better number. But let's do some math really quick and see what my range would be if I was getting 2 miles per kilowatt hour, and then, you know, at minus 2 degrees Fahrenheit. So let's check it out. So that would be a range of 154 miles, and for minus 2 degrees outside, you know, it's not great, but it's not terrible either, so I'm pretty impressed with it. I want to say, more realistically, if I was doing a longer road trip, I'd get closer to 180 miles of range, which is much better and probably more doable if I was to actually have to travel in colder weather like this and rely on the fast charging network. It might be kind of borderline. Ideally, you want to get more around 220 miles of range. But we'll see. What I'm going to do now is I'm going to see how this charger works. It's an EVgo station. It's really cold out. Does the charger work? It's pretty impressive because they're all full except for one. So this is another thing. As more people get EVs, charging stations are going to get more used, and so that's one of the big discussion topics these days, is the charging infrastructure and how much does it need to be beefed up. I was actually surprised to see that only one slot was open out of these 6 available chargers. It's kind of a shocker, but you know, people keep trying to say EVs aren't selling. To me, they obviously are, because there's a lot of people charging them up. I don't actually need to charge. I just want to do it as an experiment. I have plenty of range to get home and then charge at home, but I just want to see how well this EVgo charger works, if it even works. I have the one slot. Could be empty because it's not working. Who knows? It might also be one that only charges at like 50 kilowatts or something like that. My car has 350 kilowatt capability. So all right, I'm gonna go shopping. We'll see, and if I have issues with this charger, I will let you know. So I was actually able to get the session started super easily. I have an EVgo card, so I basically plugged it in, scanned the card, took a little bit to sync up, and now it's charging. So I'm already back to 54. So yeah, this will charge fairly rapidly. I actually have some shopping to do, so I'm gonna go shop. But this place is full, like every single station. That's pretty wild. Time to go shopping. Oh, and just to bring up another issue, the chargers are way over there and Target's there, so they always put them at the far end of the lot. So another reason to dress warm, because I gotta walk the entire concrete jungle parking lot to get into Target, and this crosswind is kind of nasty. All right. Okay, so it's been about 25 minutes, got my shopping done, and we're gonna see where my charge is at on my car. It was down to 53% when I plugged it in. So this is still full. I actually see a Rivian pulling in right now. I don't even know if they're gonna have a spot, but yeah, and there's somebody waiting. So this is a problem. More EVs than there are chargers available, and that's one of the big things that needs to be resolved, because you see people waiting all the time, and that's just not cool. So yeah, let's see what state of charge my car is at. So I did a whole video on this, and I want to talk about it now because here's the opportunity to talk about it. EVs are great. I love them. I am definitely all in on EVs, but we have a ways to go yet, and here's why. I was in there for like 25 minutes, and the key here, I only got charged not even 10% in 25 minutes, and the key here is that was showing 38 kilowatts of charging speed. That is not fast charging. I mean, yes it is, but it's very slow fast charging. This car has 350 kilowatt capabilities, and it is just trickling along. Couple of reasons for that. One, it's cold, and in the cold the cars don't charge as fast. Two, you have all the chargers being used, and so they get kind of maxed out to capacity, and so when you have a bunch of cars on the chargers, everybody's going to be bogged down and charge slower, versus if you have only a couple of cars on the chargers. And this Rivian now is sitting over here, and they're just going to have to wait till a spot opens up. Unfortunately, if they are actually waiting to do like a full charge, they're going to have to pull in, plug in, and wait a very long time, especially if it's at this slow of a rate, because Rivians even have bigger batteries. So it really depends on what state of charge they're at. So I think what I'm gonna do, because I don't actually need to charge my car up here, is I'm gonna do the courteous thing and unplug and get back on the road and do the rest of this test here, right? But a little information here for you, and I'm just gonna charge at home because I'm plenty of range to get back home, which is kind of why I wanted to do this test the way I did it, because I know that if I went and pushed the limits of my range and then expected that I was going to be able to easily fast charge, it wouldn't be quite that great. If I was on a road trip, I would actually plan for this, and that's important to do, at least in this day and age, until the infrastructure gets much improved. You definitely want to plan for your trips and where you're going to stop, and plan that it's going to take a little extra time. One of the other things I do know is here in the Minneapolis-St. Paul metro area, there are not that many fast chargers. Like, if every Target had these, there's a lot of Targets, but this was the only Target I could find that had a fast charger at it. There's a couple that have slow chargers or that have Tesla chargers. We'll talk about that in another video, because Tesla is going to open up their network to all EVs, and that's going to make a significant difference. But because there are not that many fast chargers, then everybody's trying to come here and charge. I highly recommend, if you live in a big metro area and you own your property, or even if you rent, at least try to encourage the people that you're renting from to have EV charging available in the home, because that makes life so much easier. Because if these people are actually charging this way for their daily driver and they live in the city, this is just not ideal. Lots to talk about with this experiment that I'm doing, but yeah, I'm gonna unplug, let somebody use this charger, and then get back on the road. Okay, and before I unplug, I want to just give a little piece of advice. You can hear the fans and stuff blowing. I want to warm up my car before I unplug from the charger, and by doing that, I prevent from having to use the battery to do that. So that'll just give you that much little bit additional range. So when it's this cold out, while you're still plugged in, start your car up and let it warm up, then go ahead and unplug and get on the road. Sweet.
Continue on I-94 west for 1 mile.
Okay, so heading back, I've gone 7.4 miles, and I'm averaging 2.1 miles per kilowatt hour, and that's been going up. So I'm definitely getting better range on my way back. So I'm gonna you know, ignore the GPS again and go a little bit longer than I would normally go to get back home, just to see if this miles per kilowatt hour gets better over a longer drive. And yeah, then we get a better idea of what it would actually be like, what the range would be like
In half a mile,
you know,
take the 230
on a longer drive or a road trip or something like that. So yeah, let's keep it going. So I've gone 19 miles, and my miles per kilowatt hour is staying pretty steady at 2.2. And I've been driving between 65 and 70 miles per hour pretty steadily now for a while, because I'm out of like the major traffic. So it's not dropping and it's not gaining. So my guess is that this is it. We'll see when I get home. I do have to drive on some side streets and I'll get some regen and stuff like that. So if it jumps up, oh, okay, never mind, it just jumped up to 2.3 while I was going 67 miles per hour. So, and it's pretty windy out, so it's, yeah, it's right in there. So we'll see. Okay, so here are my drive numbers. I went 27.7 miles, 2.4 miles per kilowatt hour. That's better than I was expecting. 0 degrees according to my car. So yeah, let's do some math and then I'll get right back to you. Okay, so that 2.4 comes out to about 280, or sorry, I wish it was that much, 185 miles of range. So if I stayed steady at 2.4, I would have 185 miles of range. That does come with some caveats, though. You generally don't go all the way to 0. So I would, you know, to play it safe, I would say 160 miles. When it's this cold out, you definitely don't want to, you know, push the limits on your battery like that. But that's better than I was expecting. I was just having somebody, you know, one of these anti-EVers trying to tell me that in Minnesota in the wintertime you only get 50 miles of range on your EV or whatever. And it's like, yeah, if you have an old Nissan Leaf or an EV, like one of those older ones that only gets 100 miles or 150 miles of range, yeah. But this car has an EPA estimated range of over 250 miles. I don't always remember exactly what it is. And in the summer, city driving, I easily do over 300 miles of range, and highway in the summer, driving around 70-ish miles per hour, I get about, you know, 230, 240 miles of range. Over 70, it starts to drop off, and that's also the case here. I was mostly driving between 65 and 70, and because I was in the city, there were times when I slow down and I run at level 3 regen, which isn't one pedal driving. I pedal is one pedal driving, but level 3 regen is pretty nice, because when you let off the accelerator, the car will slow down. You can really kind of control its speed really nicely at that level on the highway. Then when I get into the city, I flip the paddle and go to I pedal, which is one pedal driving, and that allows me to come to a complete stop. But I don't generally drive in that mode when I'm on the highway. So I'm pretty impressed with how well the car did, being how cold it is. That's, you know, today's state of EVs. This is one of the better EVs. It has a heat pump, all-wheel drive, all that stuff. But there's a couple of areas that need to improve for EVs to be more of like something people want to road trip with more regularly. I have road tripped with an EV a couple of times, and I don't mind it. honestly. And last year I did it in a car without a heat pump, and it was 17 degrees out, and it didn't even get close to this range, and I was able to do it. I just had to stop a little bit more often than I would generally like, and the charging speeds weren't very high on that car. So those are kind of the things that need to improve, and that are actually are improving as I speak. That's the big push right now, charging infrastructure and things like that. And then you know, ranges. So as some newer technologies come out and EVs start pushing 300, 400 miles of range, well, then it all of a sudden changes the game like pretty quickly, if that's the case. Because then in the cold weather, if it gets sapped, and from my understanding, from what I've been reading, solid state batteries actually don't get as affected by the cold as much as lithium ion batteries, because lithium ion batteries have that liquid electrolyte. It's more like a gel or whatever, and that's one of the reasons why they do poorly in the cold, or less efficiently. I wouldn't necessarily say they do poorly. I'm impressed with what my car was able to accomplish today, being how cold it is outside. It's not like, this is only a few days of the year here in Minnesota. It's not this cold all the time, and I rarely ever road trip when it's this cold. I don't like to road trip when it's this cold out because the roads are sketchy, things like that. I generally road trip when the temperature is way warmer. So but people do road trip this time of year. I mean, certainly over the holidays and things like that, and so on. So there you have it. I hope you liked this video. It's been a while since I've done a video. I've really been wanting to do this particular one, to really test the car when it was really cold out. Unfortunately, I mean, and I say that because of climate change, it's been way warmer than it should be. December was ridiculously warm here in Minnesota, and we have little bits of snow here and there, but we have yet to have like a true snowfall. We just have this little light covering that just happened a few days ago. Up until then, it was all grass. There was no snow. So that gets me a little nervous, and is more reason to push this kind of shift to EVs, so we can help the environment and stop like this climate change trend. There you have it. I appreciate your support for my channel. Please like and subscribe. Peace. Now I'm gonna go get some more coffee.